10. It's 10, isn't it?
Yeah.
Yeah.
So that's the one I wanted to check, the -1.
Right.
Okay, how about this one on the left?
Okay. Okay. So x squared. So basically, looking at 1. 1 would be 1 times 1, which is 1.
Mm-hmm.
And then minus the 4. 1 minus -3.
Yes. And so what would you get when you sub in -3?
-3. Okay, so this is going to be, it's basically -3 times -3, which is 9. It's a positive 9 because there's 2 minuses.
Mm-hmm.
So positive 9 take away 4, which is 5.
Well done. So that one is 5. -3, 5. What type of graph will you get for this one, do you know?
Oh God. It's
Just in general, because it's clearly not the same as that.
Yeah. Is it?
Just a curve.
Oh, it's a curve, right? Okay.
Yeah. And so and how would you? Yeah. So basically, you don't use your ruler with a straight line, which would be a straight line graph. This is a curved graph,
Right.
and so you just do a smooth curve.
Okay.
That's the most accurate way to do it. That's good. Let's do this one.
Okay. Table. So y. So starting 3. That's basically 3 is 9. 9 take away 4. No, 4 take away 9. It's 4 down. That'd be -5.
Well done. Try this one, -2.
Okay. That would be +4. So +4 take away 4 is just 0, so it'll just be 0.
Well done. And what you'll see is so -3, -5, -2, 0, -1, 3. We had 2, 0, 3, -5. And so you can kind of see the pattern to it. And you can see it's kind of symmetrical as well. And so if you got an answer for something, let's say your answer for 1, so I'm expecting it to be symmetrical with this -1. And if instead you got that, and you're kind of seeing how you would get a smooth curve except for that one point, then maybe double check that one.
Sure. Okay.
That one's probably wrong. And so that one should be replaced.
Mm-hmm.
And even if you're, you can kind of just see, no, that should go there.
Yeah.
Okay.
Sorry, someone just knocked on my door.
Okay.
Just give me like 1 minute. I'll be very quick.
Okay.
Thanks. Sorry. Sorry about that.
All right.
Okay. Which one am I looking at there? Oh, C. So on Tuesday, how many minutes? Holly took less time to get to school on Tuesday than on Monday. So time taken. So it took on Tuesday. It took 10 point. Sorry. 11 minutes.
How about the other one?
The other one. So it took 30 minutes. Right? Okay.
So that is 2 little squares across from 10.
Right. Okay. This always catches me out, this does. So 1 square, so there's 5 squares, so each square should be 2. So that's
Why would each square be 2?
2, 5. Sorry, 2, 6, 8.
There are 5 squares between 10 and 15.
Yeah. So 5 squares. So 5 divided by 5 is 1.
Mm-hmm.
Oh, so each square is just 1. I'm just overcomplicating it. So yeah. Okay. Right. So in that case, then 12 minutes. It took 12 minutes on Tuesday.
Mm-hmm.
So it took less time to get to school on Tuesday than on Monday. How much less? So it's 30 minutes. So 30 take away 12,
Mm-hmm.
which is 20, 18.
Yes, 18 minutes. Great, that's fine. How about this?
5 p.m. Complete travel. So at 5 p.m. stop 30 minutes. So 30 minutes. It'll just be a straight line.
Mm-hmm.
Halfway between 5 p.m. and 6 p.m. So it'll be a straight line. That means he stopped for 30 minutes. Then he cycled home at a steady speed. It took an hour and 30 minutes to get home. So an hour and 30 minutes from 5:30. So that's 6:30. 7 o'clock. So there'll be a line going down to 7 o'clock.
Well done. Great. Okay, how about this first one?
So average speed is 30 miles per hour. So 30 times 4, it's 120. It's 120. How far does he travel? Miles? Yeah, 120 miles.
Yeah, excellent.
speed. So 200 divided by 4 is 20.
How many 4s in 20?
4s in 20? 5, sorry. Yeah, so it's 50.
Yes, that's it. 50 miles per hour, because that was miles and that was hours.
Yeah.
How do we do this?
Okay, find a gradient. Straight line drawn on this grid. Gradient. Haven't actually looked at this yet. Gradient. Is that to do with the sort of the slope?
Yeah.
So find the gradient.
So it's basically rise over run.
Right.
And that means for every one right, how many up do you go?
Right.
And there's a fancy formula for it.
Okay.
So for every one right, how far up do you go?
So every one right. All right. So you go up. That's 1.5 squares.
Yep. And so the gradient, and we use letter M for gradient, is 1.5.
Right.
So it's for every one right, how many up does it go? That's the gradient.
Okay.
And there's a fancy formula for it, which we can look at another time if it comes up.
Right.
Okay, how about this?
Okay. So she's driving home. Maybe last 1 hour. And she drives. So she starts her journey. Stops for an hour. She drives a steady speed.
So it's similar to the previous one. So her meeting lasts an hour.
Right. Oh, so the meeting lasts an hour. So that's time. So that's 2:30. So the meeting will last from 2:30 to 3:30. So a straight line to 3:30.
Yeah. And so the difference between this one now is we have to find what time she gets home at.
Right. She drives at a steady speed of 100 miles per hour with no stops. 30 miles per hour, no stops.
What is the distance home?
30 miles.
No, from the graph.
Oh right. Distance home. Oh, so it's basically 30, and then 45 miles.
Mm-hmm.
Then, so, yeah, 45 miles.
So we want the time.
Right. So, you divide something here, don't you? So is it distance
Mm-hmm.
divided by speed?
Yep.
So 45 divided by 30.
Yes. 45 divided by 30. 1.5. And so that's 1.5. What's the unit for time?
So it's every one small square is 10 minutes.
Okay. Okay, so what time does she get home?
So 1.5. So an hour and a half. So that's from 3:30. So 4:30, 5 o'clock.
Well done. And so the previous one gives you the it gave you the time. This time they gave you the speed, and you had to read off the distance and calculate the time yourself by doing distance divided by speed.
Right.
Any questions there?
No, it's pretty logical. I think should be okay.
Well, not always obvious. Okay, how about this?
Okay. Work out the range of the test marks. So it's going to be 10 take away 2,
Mm-hmm.
which is 8.
Well done. That's all it is. That's great. Okay, the one on the left.
And it's the shortest side of the isosceles triangle. So that's going to be the base. Mark and so that's the isosceles triangle. So it's going to go straight up through the middle.
Yes, and so where is the middle?
The middle would be 5.
Yes. Yeah, so just anywhere along there, and I'll just do it at the very top. How about the one on the right?
Okay, I'm going to create A, B, C. Not cross. So, yeah, basically it'll be like through 1.
Yeah.
So it'll just be going like down. So along sort of positive 1, just down that line somewhere.
So pick a point.
So 1 minus 4.
Yeah, great choice. So the only one you couldn't choose was this one here, because then I think it would maybe be a rhombus or something, because then that would be exactly the same length. Okay, that's it. Okay, how do we do this?
Okay, find coordinates of the midpoint G to H. So the midpoint looks like it's 0 minus 1. No, sorry, 0, 1. Oh,
That's 4. Yeah. That's minus 4. 0, 1 is correct.
Yeah.
Fine. So that's geometry done. Now it's time for shape. Let's first do the one on the right.
Right, okay. Look at the angle of X. So we know that the one on the top right is 90. That's a right angle. So this should be, all the angles should add up to 360.
Mm-hmm.
So it'd be 90 plus 37 plus 128, and then that answer subtracted from 360.
That's it?
Gives you A.
And how about the one on the left?
Okay, BC is a right angle. Triangle. D, just straight line. Work out the size of the angle marked X. So A is 90 degrees. So basically 90 plus 58 plus 37. You subtract those three from 180.
No, they're not in a those three aren't in a triangle together.
All right. Actually, hold on. Are those opposite angles, aren't they?
No, they'd have to be a parallel line. Is there any blank you can fill in if you're not sure?
So, okay, so you can do it individually, I guess. So, so we know that A is 90, D is 58. So the angle in the corner by C, the invisible one, you would sort of subtract 90 plus 58 from 180.
Yeah, and you would get 32.
32. So
so what if you were to consider that there's actually a third triangle, which is the big, huge one?
Right, okay. Okay, in that case, so we've got 37. I see, so it'd be 37 plus 90. It'd be 180, take away 37 plus 90. And then whatever the answer is, you subtract 32 from the answer, and that will give you X.
7 minus 32. And so X is 21. That's it. Yeah, so if you're not sure, just fill in some blanks and consider that there's 3 triangles in total. One on the top, one on the bottom, and the total triangle as well.
Right.
Any questions there?
Yeah, it's just the whole thing of filling in blanks, like you said.
Yeah, because it's not obvious which to do first or whatever, so you just... okay, how about this one?
Okay, Less than 10%. So we know that all the angles have to add up to 360. So it's basically 10% of 360 is 36.
Okay.
It's just saying less than 10%. Less than 10% of the students in year 11 car. So it says 40%. So that's more. So it's incorrect.
Yeah. So incorrect. So he's incorrect. Great. Okay, how about this one?
Okay, interior angles. 140. What is this side? So 540 divided by 5 gives you your answer.
Yeah. What is 540 divided by 10?
54.
And then double it?
Double 54. So that's 108.
Yeah. So that's the easy way to divide by 5.
Right.
What would you do here?
Okay. That's a 1080, which is the size of 1. Interior angle. So it's so there's not, so 1080 divided by 9.
I
Correct?
believe it's 8 sides.
Oh, so it's divided by 8.
Yes, and the easy way to divide by 8 is to half it
Right.
3 times.
Half it 3 times, okay. So 540.
Mm-hmm.
And then half of 4, so half of 50 is 25.
Well, half of 500.
Half of 500 is 250.
Mm-hmm.
So half of 40 is 20. So 250 plus 20, 270.
Mm-hmm.
Half of 70 is, that's half of 7 is 14, so 35, so 135.
Well done. Yes, so I think you're good for those. And if you're ever stuck, just do the long way of division.
With those questions, would those be non-calculator questions or?
They strike me as non-calculator.
Right.
Yeah. But it's even just kind of a question will ask you on a non-calculator to divide by 5 or divide by 8. So it's just good in general.
Yeah, it's good practice.
So divide by 5, you can divide by 10 and double it. To divide by 8, you can half it 3 times,
Sure.
Okay, what is this about?
Okay. So in the space bar, draw a sketch of a net triangular prism. So would that just be opening it up?
Mm-hmm.
So be 2 triangles sort of one facing forward at the top,
And
and
what?
then a
What?
rectangle.
Yeah. So I think the rectangle is the
Right.
place to start from. So there's a rectangle.
And then so like a triangle, like a downward facing triangle,
Yeah.
and then an upward one as well,
Mm-hmm.
and then the sides, like rectangular sides.
Well done. Okay. Let's try bottom right.
Okay, so or just the base is just a square,
Mm-hmm.
and then it'll be just a square up, and then a square below, and then on the sides, and that's it.
This has 5 sides.
Oh, yeah. So there should be another square.
Yes.
It's just
Yeah. So one of them has 2, and so
right.
that one goes over the top.
Of course.
I think you're okay for these. I think you get the idea.
Yeah.
So some of them are okay. How about this on the left?
On the left. Okay. So. Make an accurate drawing of the cuboid. Just already drawn for you. Okay, so we're going to go up 2 centimeters, which will be go up 2 dots.
So it has to be at a right angle to the 3.
Alright.
And so it wouldn't be up on the dots. So perpendicular on the dots. So this one is going diagonally down.
Right.
And so perpendicular on the dots would be diagonally up, if you like, diagonally increasing.
Right, I see.
And how many dots diagonally would it be?
So 5.
So this is perpendicular to the 3.
Well, it's perpendicular means like straight up from the 3.
Yeah, like right angle.
Right angle. So it'd be 2.
Yes. So same there, 2. And that's like that. So that's the rectangle. So if that's the 3, then that one is the 2.
Right.
And then how would you do the 5?
The 5. So perpendicular from the 3.
Oh, you're teaching.
It's really weird. It's because it's like it's not.
Yeah.
It's really confusing.
So the only other direction that you've got, instead of diagonally up or diagonally down, the only way you can go now is vertically. And so I'll just go up. How many dots up would it be?
5 dots?
Yeah. 5. You need to do that for each corner. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And that's, and then you just join those up.
See.
Yeah. Okay, so the one on the right is exactly the same. It's just that instead of using dots, it's using lines, but it's the same thing.
Right. Okay. Shall I give it a go?
Yeah.
Right. Okay, so uh, okay, so it's been drawn. So the side that's been drawn, and so it's 1, 2, 3, 4. So 4. So it would be 2 up, two triangles up.
Okay. So, they started with a black line, sorry.
Yeah.
There's a line there. So which one
Yeah.
is that?
So is that the 4 centimeters?
Yeah.
So to go perpendicular from 4, it's not going to be directly up. It's going to be it's going to be 2 sort of
Diagonally?
yeah, diagonally, yeah, not straight.
Yeah.
2.
So 2 and 2.
You can join that.
Yeah.
The 6 centimeter. So the corner, the very bottom corner, you go up 6.
Yes. 5, 6. And in fact, every corner.
Yeah.
Oh, it looks weird. Okay, any questions about this one?
No, I think I get it. It seems okay.
Yeah.
Is that a rule? Because they don't actually say in the question it has to be perpendicular from the 3. Does that?
So it would be wrong if it wasn't, because this is a rectangle here,
Right.
and then this one is going in the other direction. So if you would yeah, so you'd be doing like a 4x6.
I see.
Something like that. Yeah.
Okay.
Okay. How about this?
Right. Draw the view of a solid shape and direction. The view. So I guess it would be you'd see a square on each side of the view. So
Right.
I'm not really sure.
So how many squares along the bottom? How many up? So you're taking something that's 3D and now you're gonna draw 2D.
Oh, I see. So it's like you're turning it. So if you were to turn it around, it would just be 2 squares up.
Mm-hmm.
And 3 across.
Yeah. And is there anything special about it? Would it just be a rectangle? Basically, there's this block missing.
Oh, right.
And so where would that go on the drawing? The missing block.
So, see, I would have drawn it just like where the other one is.
Hang
I
on.
would have, yeah.
So, is that what you were thinking of?
That's what I was thinking. Yeah.
Yeah, and there's a space in the middle. That's it.
Yeah. Okay.
Okay. How would you do this one?
Right. Square base. Draw a full size accurate plan of the pyramid. So I guess so for the base it would be 6 centimeters at the bottom, like 6 along.
Okay.
And I want to go 6.5 centimeters up, so 6.5 squares. Actually, no. So it's an isosceles. So through the middle, halfway through that line, which forms the base, so third, like 3 squares along in the middle, go right up top.
So I would start by doing the base first. So what else could you draw with the full base? Like with our net, you kind of. So a plan is like a top-down view of it. So what it would look like if you were looking at it from the top down, like a bird's eye view.
Oh, okay. So in that case, there'd be a parallel line. But I don't know the. I know it's 6. Oh, for square base. Here's a pyramid square base. Oh, so it's a square. Okay. So it'll be 6 up.
Yes.
Yeah.
4, 5, 6. And so what would this look like from the top?
From the top, right dead in the center would represent the point.
Yes. And so
you just draw the line point.
Yeah, hopefully that's both going through the center, and it is. And so I'm sure it's 6.5 long, but we don't need to do it, and that's what it looks like.
Ah, great.
So, sorry, go on.
Just going to say, how many marks does that? These are all two?
These are all 2 marks, yeah. All 2 marks. And so sometimes that tells you, like, if something's 2 marks and it seems like it's going to be a lot of work, that is probably a simpler way of doing it.
Right. Okay. I'm going to draw a plan of the cuboid.
So this time you're kind of working in reverse. They've given you the front and the side, and you have to draw the plan.
Draw the plan. So, okay. So that's a cuboid. So 4 and 3 is the side elevation.
Yeah. So let's say 3 and 6 is the front. 4 and 3 is the side. So the 3 matches up with the 3.
Right.
And so the other one is 4.
Oh, right, okay.
Because each of those are a rectangle that is 3 by 4.
Right.
And so what is the top?
So so
So what are the dimensions of the rectangle on the top? So the front is 3, 6. The side is 3, 4.
Oh, so it'd be 4, 4, 4. 4x6.
Yes, 4x6. And so you just do one. That is 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. So 3 is the shared side.
Right.
And so the one on top is going to be the other two. Okay, how about the one on the right?
Okay. Undergo draw an accurate plan of cuboid. So a plan is basically, it's like looking down.
Yeah, it's like the roof.
Right, the roof. Okay. So the front. Okay. So the front is 4 up. So it's 4 by 6. 4 by 6. Side elevation. So side elevation.
Yeah.
So what should I be looking at? It says the side elevation.
So if this is the front,
right?
You could draw the side. So how would we draw the side?
So we know that the side is 4 long.
Yes, that's the shared side.
Yeah. So
how many diagonal or whatever?
So yeah, it'd be 4. Is it 4 along? Yeah, 4 squares along.
So we already have the 4 side.
Oh,
What are the dimensions of the side?
is it 6?
The side?
Oh, so it's 4 by 3.
Yeah. And so we already have the 4, and so we do 3.
Just 3, right?
3. And so you can see there that if that one's 4, this one's 3.
Right.
And so, what is the top?
So, so it's okay. So the side is 3. So it's 6 by 3.
Yes, 6 by 3, and that's because those are the sides that they don't have in common.
Right.
And so 1, 2, 3, 4, 5, 6. So they asked us to draw it.
Right.
And so we're drawing it. So that down there is like our working out, and
right.
This is our answer.
That's the actual answer. Okay.
Yeah, that's the plan. It's 2D. Yeah. Any questions about that?
It's a bit. It feels a bit alien, this, but I guess I'll just have to practice it.
Yeah. Okay. How about this one?
Okay, so as a diameter 140, work out the circumference of the circle. So it's pi times radius. The diameter is half the radius.
Yeah. And how do you find circumference?
Pi times radius squared.
That's area.
Oh, just pi times diameter.
Yep. And so this one.
So I have to use my calculator. So just bear with me.
So what would you put into your calculator?
So 140 shift pi.
Yeah.
And it's the actual answer. It's asking 3 significant figures, so it'll be 440.
440, that's it.
Yeah.
440 centimeters. Well done. How was that for you, Pierre?
Yeah, it was generally fine. It was just just towards the end it got a bit iffy, but yeah.
So that's the stuff I think you haven't seen.
Yeah.
But so that's what it is anyway. You just draw the top. You just do a little sketch.
Sure.
Yeah. So we've done half of the first half of that. So we're kind of did geometry and we're now into shape.
Great.
So continue this next time.
Brilliant. Okay. Great. So we have how much? So we've got. So you said we're halfway through shape.
So we're halfway through geometry and shape. So
right.
What I really wanted to get finished was the 2-mark questions, 1 and 2 mark, because they comprise, like if you get every 1 and 2 mark question, then you pass.
Right.
And so I wanted to get at least every 1 and 2 mark question.
Brilliant.
And so 1, 2, I'd say maybe 3 more lessons and that would be done. We'll see what the 2-mark data is like. It might be big, so it might be 4 more lessons, but we'll see.
Sure. Okay. Great. Well, yeah, I'll just keep soldiering on the textbook and all the exercises you sent me, so I'm sure it'll be fine.
Yeah. And any questions for me in general?
No, that's pretty much it, really.
Okay. Well, yeah, well done, Pierre. You did great. And I look forward to talking again. Is it
Tuesday?
Tuesday, yeah.
Tuesday, yeah.